2.4 linear functions. And this is our graphing section, so you might want to write out beside graphing. In 2.4, we're going to be graphing lines, okay? We're going to be graphing lines. So first, we need to know how to find the slope, okay? And slope is represented as lowercase m. So when you see lowercase m normally in algebra, that is signifying slope. So the slope formula says we're going to take our 2 points, subtract the y's over the subtraction of your x's. Now, I normally do the first point before I do the second point, but in the textbook, and you might even see it on my labs, they might do the second point before the first point. These are the exact same formulas, okay? So there's no difference in the formula. You will see me working my problems utilizing that first one, okay? So very simple. I'm going to give you 2 points, and we're going to plug it in, and we're going to find the slope. So first example, if we were to have the points 2, -1, and -3, -3. We're going to plug it in. Our y numbers would be -1 minus a -3. And we know that 2 negatives make a plus. Over 2 minus a -3. And again, those 2 negatives make a plus. So we have -1 plus 3, which is 2, over 2 plus 3, which is 5. And our slope is 2/5. Always check your fraction to make sure it cannot be simplified. And 2/5 is already in lowest terms. Second example, -12, +3, and 4, 1. XY, XY. So we're going to plug in our y numbers, 3 minus 1, over our x numbers, -12 minus 4. So 3 minus 1 gives us 2. -12 minus 4 is a -16. And we know that 2 over -16 reduces to a -1/8. And that's your slope. Third example, we have 5, 9, and -2, 9. And so we're going to plug in. Our y numbers would be 9 minus 9. Our x numbers would be 5 minus a -2, which we know that makes a plus. But I hope you see that 9 minus 9 on top is 0. And you should know that 0 on top of any fraction is 0. So the slope is 0. Granted, 5 plus 2 is 7. But when 0 is on top, then your answer is 0. And our last example on finding the slope, given 2 points, we have 3, 4, and 3, 2. Plug it in. We have 4 minus 2 over 3 minus 3. And 4 minus 2 is 2. And 3 minus 3 is 0. This time our 0 is on the bottom of the fraction. So this kind of links back. When you have 0 on the bottom of a fraction, then that means that the fraction does not exist. So what we say in graphing is that the slope is undefined, okay, undefined. And that's what you have to tell me. Not a number over 0, but that equals undefined. So undefined and 0 slopes are our special slopes, okay? And we'll talk more about them when we get into graphing lines. So right now, the first 3 of 4 examples was on finding the slope, given the slope formula. All right, linear equations, which are our lines, they come in 2 main forms. You have ax plus by equals c. This is known as our standard form. Our second form is y equals mx plus b. This is known as our slope intercept form, okay? Now, for graphing in this section, I would like for you to have your equations in slope-intercept form. You can plot points, you can plug into a t-chart, you can graph using the x-intercept and y-intercept, and I will show that. But I really would like for you to be able to take an equation, and normally your equations come in standard form. And all that means is that x and y are on the same side. Slope-intercept form, y is by itself. And in slope-intercept form, the reason why we kind of like to graph with our equations in slope-intercept form is mainly because all I need to graph is a starting point and I need my movement. So m, we know, represents the slope, and b represents what we call the y-intercept. It's the reason why it's called slope-intercept form. Because in this form, you're given the slope and you're given a starting point, which is your y-intercept. So I'm going to give you some equations. We're going to graph some lines. We're going to transfer our lines from standard form to slope-intercept form. So here's our first equation. All right, our first equation is x minus 2y equals 6. Now, this is standard form, okay? And it's standard form because x and y is on the same side. So I would like for you to put it in slope-intercept form. You'll change to slope-intercept form by solving for y. So that means you're going to move the x over. Keep in mind, your ultimate goal is to make it look like y equals mx plus b. So you want your x number, then the whole number. So I'm going to move x over, and when I move it over, it becomes a negative x. 6 is our b. It's already over here, so I'm just going to put plus 6. Well, it's our b in the making. It's not technically b. And now you're going to divide by negative 2. Because you got to get y completely by itself. So when you divide by negative 2, this is an understood negative 1. So negative 1 over a negative 2, you know, reduces to positive 1/2 x. And then 6 divided by negative 2 is negative 3. So that's the exact same equation, but this is slope-intercept form. This is the form I want you to have your equations in. Now, in this form, you have 1/2. That's considered your slope. And then you have negative 3, which is your y-intercept. Okay, that's our b. Now, making sure that you understand what slope truly means. Slope is nothing but your movement from one point to the next. And you do that movement by doing rise over run. And I just like to run. It's all R's. So I rise, I run, and I run right. Okay. That might help you memorize or know which direction you should go. But we're going to run our lines, our dots to the right side until we're comfortable to make our dots on the left side. Okay. So we're going to rise, go up, and then we're going to run. So if we look at our equation, y equals 1/2 x minus 3, we're first going to put our first point on the y-axis at -3. So keep in mind, the y-axis is the axis that goes up and down. So you're going to go to -3, 1, 2, 3. And from that point, we're going to do the slope of 1/2. So I'm going to show my movement in yellow so you can see how I made my next point. From that point, I'm going to go up one line. That's rising. And I'm going to run to the right 2 lines. That's where your next point would be. Do it again. We're going to go up 1 line, over to the right 2 lines. That's where the next point will be. You can continue to do the slope over and over again, and it's going to do nothing but create more and more points on your line. Up 1 line, over to the right 2 lines. Okay? Now, all you need on my test is 3 dots. I need to see 3 points. So you at least got to do the slope twice. Now, you also, from that y-intercept of -3, you do know there are points on the left side. You also can come down 1 and over to the left 2. And you see that point will also diagonally line up with the other points. So if you're not comfortable with making points on the left side, just give me 3 good points on the right side and then connect them and then draw arrowheads. Those arrowheads let us know that the line is continuously moving. Okay, it's not stopping, it's continuously moving. Now, on the last test, well, you haven't actually had that test yet, but you have gotten the material for it. We talked about domain and range. And so all of our lines that have a slope, their domain and range should be the same. If this line continuously goes from left to right, you know the domain will be from -infinity to +infinity. This line is on the left side of the x-axis as well as it's on the right side of the x-axis. The range would also be from -infinity to +infinity because this line is going to come up into the top part for y, and it's also in the bottom part, the negative part of y. So don't forget domain and range because you will be asked domain and range on these lines. Let's look at the next example. All right, our next example is 2x minus 3y equals 12. So again, this is in standard form. Let's put it in slope-intercept form by solving for y. So that means that this 2x needs to move. And when it moves across, it changes to a -2x. Okay, plus 12. And then you're going to divide everything by -3. So that's going to change signs. So -2 over -3 means a positive 2/3 x. And then 12 divided by -3 is -4. So our equation would be y equals 2/3 x minus 4. That's in slope-intercept form. So 2/3 would be our slope. And -4 is our y-intercept. So that means on the y-axis, that's the one that goes up and down, you're going to put your first point at -4. Okay? And from that point, we're going to do the movement, rise over run, 2/3. So that means we're going to rise, two, and we're going to run 3. So we're going to go up 2, 1, 2, and we're going to run 3. 1, 2, 3. So your next point would be there. We're going to do it again. We're going to go up 2, over 3. And like I said, 3 points is all you need. You can draw your line and connect it. But there are also points on the left side. So you could go down 2 and to the right 3. And that point you see will diagonally line up as well. Once you have 3 points, at least 3 points, connect them. And you would also see that your domain and range would be negative infinity to positive infinity. Okay? Now, I do want to also mention how you should be able to find x and y intercepts without even graphing it yet. Okay? So, if we're going to take this same equation, 2x minus 3y equals 12. And what if, and I know my labs might ask you this, they might ask you to graph using just merely the x and y intercepts. So if you are asked to find the x-intercept, that just means where it crosses the x-axis, and we haven't talked about that. But these lines, if they're diagonally, if they have a slope, they're going to cross the x and the y-axis. So if we're looking for the x-intercept, you can't solve an equation with both variables to actually get one solid number. So you're going to have to let the other variable be 0. So if I'm looking for what x is, then I got to let my y be 0. Okay? And that's just something you need to know when you're doing graphing. So if I let y be 0, technically it's gone. And since you can't really just see my movement, I normally cover it up, but I'll show the plug-in so you'll see that this is gone. This is 0. So you just have 2x equals 12, and when you divide by 2, x equals 6. So that means that this line is going to cross the x-axis at 6. Well, if we look at our line, we got 1, 2, 3, 4, 5, 6. Surely does. Our point does cross the x-axis at 6. So you could have plotted that point first if you're asked to just plot 2 points. Now, I will not ask this really on my test, but my labs might. They might ask you to graph this line by just plotting the x-intercept and the y-intercept. So you would need to know you're going to have to let y be 0 in order to find that x-intercept. And that's where it would cross the x-axis, is at 6. Now, the ordered pair for that, normally we write our intercepts in ordered pairs. The ordered pair would be 6, 0. Because you do know the x part has to be 6, and the y is what you let be 0. So kind of keep that in mind. That's the ordered pair for that point. Now, if you did not put it in slope-intercept form, this equation, then you can do the same process on finding the y-intercept. This time, you're going to let x be 0. Okay? So always remember, when you're looking for an intercept, you got to let the other one be 0. So if I let x be 0, that means that where x is, you plug in a 0, which technically means it's gone. That's gone. So we just have negative 3y equals 12. And when you divide by negative 3, y is negative 4. And if you remember, that's what we got when we put it in slope-intercept form. And that's that y-intercept at negative 4. Okay? So you can graph really multiple ways, but I really on test you need to graph using the slope-intercept form. But I did want to show you how you can graph by just plotting the intercepts. That's your x and y intercept. Now, this 2, you need to know how to make that into an ordered pair. And that would be 0, -4. Meaning, your x is what you let be 0, and your y is what you solved and got -4. Okay? Okay, our next graph is x plus 2y equals 8. X plus 2y equals 8. So again, we're going to put this in slope-intercept form. And I just want you to get the practice of putting stuff in slope-intercept form. So that's going to give us 2y equals -x plus 8. And then we're going to divide by 2. So y equals -1/2 x plus 4. That's our equation. Now, our slope is -1/2, and our y-intercept is +4. So when we graph, you're going to put your first point on the y-axis at +4. Now, this time our slope is negative, okay? And you're going to have to do a negative movement. Rising, going up, is a positive movement. Going to the right is a positive movement. But when you go down, that's a negative movement. When you go to the left, that's a negative movement. So I'm going to do one negative movement, okay? So I'm going to go down one line. But since I went down, I must still go to the right. So that's kind of the reason why I always say I run right, so I won't confuse students. But I take care of the negative by going down one, okay? I went down, I go to the right 2. Go down 1, right 2. Down 1, right 2. Do you see that? Now you could go up 1, but in order for you to make it negative, up is positive. You got to go to the left as your negative movement. And see, that's how your points are lining up on the same line. So once you have at least 3, connect them. And if you notice, we talked about increase, decrease, and constant. When you look at this line and you start from the left side and you follow it, you are going down. You're decreasing. Okay? You're decreasing. And it should be decreasing because your slope is negative. Okay? So kind of let that resonate and kind of make sense to you, because if you have a positive slope, your line, like here, we had a positive slope. And if we follow it from the left going, you see we're going up, we're increasing. That's because our slope is positive. Here our slope was negative, so we were going downward. And you do know we read this from left to right. Again, our domain and range would be negative infinity to positive infinity. All right, our next graph, we have 5y plus 3 equals 18. So if you notice, I'm missing x. I don't have x and y. I just have y. So this is a special line. So we're going to solve for y. We're going to subtract 3. And then we're going to divide by 5. So y equals 3. Okay? Now when you go to graph, we're going to go to the y-axis at +3. Now at +3, if you notice, there's no x in the whole problem. So let that be an indicator that you will never cross the x-axis. This line will never cross x. It can't touch x. It does not have an x, okay? So the only way you can go through that point is to go horizontally. Do you see that? That's the only way. There's no X. Okay, so it can't cross X. The only way you can cross X is if there was an X in the problem. Okay, so that's a special line. That's a horizontal line. Okay, now I want to explain slope. Let's talk about the slope of that line. And again, we do rise over run when we look at slope. That's our movement. Now, when you look at this horizontal line, and I ask myself, okay, is this line rising? Will this line ever go up or will it ever go down? That's falling. And you would say no. This line is never going to rise. But this line is running. And what I mean by running is it going left and right. And it is. It's going any number you want it to, left and right, but it's never going to go up. So when I look at the fraction, 0 on top of any number is just 0. So that tells me that the slope of this line is 0. Honestly, the slope of all horizontal lines is 0. And you need to know that. You need to write that down. That the slope of all horizontal lines is 0. Okay? Is 0. Now, I also want to mention domain and range. Now, the domain, we're talking about left and right. This thing is running left and right. So the domain would be negative infinity to positive infinity. However, my range is up and down. And this line is never going to go up or down. It's only going to be at 3. So your range is just the number 3. And I need you to see that because on the y-axis, every y is going to be 3 on this line. There is no other y of another number on a horizontal line that's running at 3. So my domain can be anything because you're running left and right. But my range is only 3. All right, our next equation is x plus 7 equals 12. Now, if you notice on this one, you are missing y. There is no y. So this is another special line. Now, I normally solve for y, but this is a special situation. This is a special case. So I have to solve for x because that's all I have. So we're going to subtract 7, and we get x is 5, okay? X is 5. So when we go to graph, we have to go to where it says x equals 5. Now, the only way I can cross this point that point without touching y, and I'm saying that just like I did on the last problem, I can't touch y because there is no y. There's no y in the equation, so it's never going to cross y. The only way I can go through that point is to go vertically. That's up and down at x equals 5. Okay, so this is a vertical line. This is a special line. This is a vertical line. This has no y, doesn't cross y. So now let's go and let's talk about the slope like we did with our horizontal line. With the slope, we know our movement is rise over run. Now, this time, our line is rising. It's rising and falling any number we want it to be. However, this line is not going to run left and right. So your 0 now has flipped positions. It's on the bottom. So if 0 is on the bottom, we talked about that. 0 on the bottom of any fraction technically is undefined. So the slope is undefined. The slope of all vertical lines is undefined. And that's something you need to write. You need to know that the slope of all vertical lines is undefined. All right. Make sure y'all have that the slope of all vertical lines is undefined. Now, let's look at the domain and the range. Now, this time, our domain, when we look left and right, we're not going left and right. The only number that's in our domain is going to be 5. That's where X is, right here at 5. Now, when it comes to our range, though, we are up and down. So our range would be from negative infinity to positive infinity. Okay, our last graph is going to be 3y equals x. 3y equals x. So to get y by itself, we're going to divide by 3. And so y equals 1/3 x. Now, you do have x and y, so this is not considered a special line. Our slope would be 1/3. And since there's nothing out here but air, then we know that the y-intercept is 0. Okay? If I wanted it to be a number, it would say +1 or -1 or +15, but there's nothing out there. So that means this line is going through the origin. So we're going to put our first point in the middle at 0. And then from that point, we're going to go up 1 line and over 3. 1, 2, 3 lines. We're going to go up 1 line and over 3. 1, 2, 3. Once you have at least 3 points, connect. And you can see that your domain and range on this one would be from negative infinity to positive infinity. And our line is increasing because our slope is positive. Now, just to briefly kind of recap, we looked at graphing, and we looked at graphing using the slope-intercept form. Solving for y is that's how you put it in slope-intercept form. The number on x would represent our slope, and the other number would represent our y-intercept. Also, if you're looking to find the x-intercept and the y-intercept, just be mindful that you must allow the other variable to be 0. So when you're looking for intercepts, you're always plugging in 0 for the variable that you're not looking for. Slopes, if they're negative, keep in mind your line should be going downward. If they're positive slopes, they should be going upward. And we have 2 special linear equations. We have the horizontal lines, which are the y-only lines, okay? They're going to be going across the y-axis. Remember that the slope of those lines are always 0. Then we have our vertical lines. They're going to be going across the x-axis, x only. And the slope of all of our vertical lines is undefined. And that's pretty much it for the section 2.4 on graphing. We'll kind of recap some graphing problems once we are back in class after you've taken your test. But I wanted to make sure I gave you some notes on 2.4 that you'll be able to go ahead and do the homework on 2.4. And that homework is due on Sunday night.